Good morning, good afternoon, good evening, depending on where you are. I, Isha Raje, welcome you all to this special event. 5 years ago, two bright young engineers from IIT Bombay embarked on a mission, space for all mankind. Today, 5 years down the line, both our founders can look back at the journey thus far with a sense of satisfaction and look ahead with optimism to conquer the new frontiers in space. At Manastu, we believe that the problems of Earth can be solved using space. With our founders, Tushar Jadhav, CEO of Manastu Space, an ex-DRDO scientist and aerospace engineer, and CTO Astesh Kumar, a combustion engineer from IIT Bombay, along with our team of talented scientists, we believe that we can make space greener and more affordable. On this very special day today for the Manastu family, it is a matter of great honor and privilege to have with us today Dr. S. Somanath, Chairman, ISRO, who is joining us to bless and guide us in our future journey. On behalf of all of us at Manastu Space, I cordially welcome you, sir. Dr. Somnath received his graduate degree in mechanical engineering and master's degree in aerospace engineering from Indian Institute of Science. After graduating, he joined VSSC ISRO in 1985. He was associated with PSLV project during its initial phase. He was the associate director of VSSC, the project director of GSLV Mk3 launch vehicle, and the deputy director of propulsion and space ordnance entity. He also served as director of LPSC and then VSSC before he took over as the chairman of ISRO in 2022. I now invite Astesh Kumar, co-founder and CTO of Manastu Space, to share Manastu's journey so far and the road ahead. Before I hand over to Astesh, I would like to inform you all that we'll have a Q&A at the end of our session. Kindly share your questions with us through the chat box. Over to you, Astesh.
Thank you, Isha. Thank you. And good morning to Somnath sir and Anil sir. Thank you for joining us today. And a very good morning to all of our participants. So I will be sharing my screen now. Yeah. Is my screen visible?
Yeah, it's visible.
Okay. Thank you. So good morning, everyone. So I am Astesh Kumar, CTO and founder of Manastu Space, and I currently lead the technology development for propulsion systems at Manastu. So, the dream of Manastu started more than 5 years before when I and Tushar led a team in IIT Bombay to complete IIT Bombay's first student satellite and launched it with the support of ISRO called Pratham. During this journey, we realized that space has the potential to solve at least some part of all problems on Earth. Be it agriculture, be it climate change, be it border security and whatnot. And to reap this benefit, there's a revolution happening out there in space. What is that revolution? In next 10 to 15 years, more than 100,000 satellites are being planned. Why? Why this revolution now? Because of drastic decrease in cost of launching and making satellites because of innovations by organizations like ISRO, SpaceX, who have done immense innovations in decreasing the launch cost of satellites, and also innovations in electronics and batteries which have brought down the cost of satellite making. But as we know that all revolutions have their own problems, and space is also on that part. When we have hundreds to thousands of cars on road, what happens? They run into accidents, they collide with each other, they run out of fuel and whatnot. Same problems space satellites of tomorrow are going to face. One of the major problems which satellites or the space industry today faces is that of space debris pollution. Currently, more than 160 million space debris are already there because of just 10,000 satellites launched in last 60 years. And going down, we see that in next 10 years, more than 100,000 satellites are planned, which have the potential to create more than 100 billion space debris. One of the major reasons why so many satellites needs to be launched is because we are still not utilizing the full potential of satellites. No, the life of satellite is limited by the amount of fuel it carries. Once the fuel is over, no matter how expensive your payload of satellite, your electronics of satellite, they all become redundant because your satellite does not have any more fuel. Because of this, satellites are designed to carry propellant for the entire lifetime, which leads to heavy propellant tanks, lot of propellant being stored in the satellites, making satellite making and satellite launching both very expensive cost. So we feel that these two are the major problems which is making space economy and which is not letting space economy become sustainable. It's like you can imagine you have a expensive luxury car with a huge propellant with huge fuel tank, and once the fuel is over in your car, you have to trash your car. Similar thing is happening with satellite. So we are exactly working on solving these two problems to make space economy sustainable. Talking about space debris, any collision between two spacecrafts can generate somewhere from thousands to lakhs of space debris, which can go on to hit another satellites, creating a chain of these events. Each of these debris are moving at speeds which are 10 times that of bullet and have the potential to destroy entire fleet of satellites and followed by litigations. And after some critical number of these events, there will be so many debris, then the orbits in space will become inhabitable. And that is why we say that space is going to become the next Chernobyl, a dangerous and inhabitable place. So how to solve this problem? To save your satellites from collisions, satellites need something called as propulsion systems. These propulsion systems needs to be very agile so that they can move these maneuvers and so that they can move out these collision courses by firing these propulsion systems in very small notices. They need to be safe and efficient because every time you do these maneuvers, you burn propellant. So you want to burn as little fuel as possible so that your life of the satellite is maintained. And needless to say, these systems needs to be very affordable so that you can plan these systems for your entire lifetime of the satellite, for the entire fleet of satellites. To solve this, we have exactly come up with a new propulsion technology with three major innovations. We have invented a new satellite fuel, which is a proprietary blend of hydrogen peroxide and additives. We have innovated a new satellite engine to burn this new propellant and a new catalyst, which are like spark plugs in your engine to start combustion. How good is this technology? So overall, this technology is 20 times more agile than typical electric propulsion systems because of their higher thrust production capacity. These are 50% higher efficiency than traditional hydrogen-based systems because of the innovation in fuel which we have done. And the propellant is as safe as common salt, which reduces the infrastructure investment required by satellite manufacturers in storing or in transportation of these toxic propellants. So overall, we believe because of the choice of materials and the choice of propellant, we will be able to offer this system at 60% more affordable cost than any other system currently out there in the world. So what benefit we will offer to our foreign customer? We believe that with this high performance green propulsion system, we can reduce the reduce the launch cost of satellites by as much as 30%, thereby generating more revenues for satellite manufacturers and also having them safe from debris collision. Talking about what are the other solutions in market, we all know that from World War till now, hydrogen-based systems have been used, which are very toxic and carcinogenic and due to be banned in international community soon. Because of this, US and Europe are making effort to develop alternative green propellants, and they have spent close to 100 million US dollars with more than 20 years of research to develop these two green propellants, which are super costly. Then we have electric propulsion systems, which are very safe, are very efficient, but they are like snails stuck on a highway because of their limitation on the maximum amount of thrust they can produce. This is where we believe that Manastu Space can bring a change. We have developed a technology which is agile, as safe as common salt, 50% higher performance than traditional hydrogen-based systems at 60% affordable cost. We have already spun out 3 product lines from this technology for depending on different weight of satellites. For greater than 100 kg satellites, we have I booster for which we are working with DRDO. Then for smaller satellites, we have Vyom 1U, Vyom 2U for smaller satellites. So we are actively working with some of the customers to develop use cases for these products and deploy it as soon as possible. After this product, after providing our customers with this high performance green propulsion system, we want to maximize the life of these satellites. We want to maximize the potential of these satellites for our customers by providing in-space refueling as a service in future. That the customer having our propulsion system will be able to dock with our in-space tankers and refuel their satellites, which will increase the life of their satellites. And once the life of satellite is really over, the same tankers will help these customers to deorbit these satellites, and all this by providing just minimum subscription fee. So they save a lot of their infrastructure cost and they increase the life of their satellites, which increases revenue for them. We believe with this combination of products and in-space services, we will be able to make space economy sustainable. Talking about the market, in next 8 years, more than 57,000 satellites are planned, which leads to satellite propulsion market being over $20 billion with a CAGR of 14.6%. And we believe that the biggest opportunity in all of this is the 100 to 500 kg satellite market. So till now in this journey, we have been backed by very strong advisors, some of them who are serial entrepreneurs themselves and are helping us develop a business strategy for selling this product. We have other experienced scientists from retired from ISRO and DRDO who have more than 30 years of experience of building these systems in these renowned organizations. We also have professors from IIT Bombay who have helped us from last 5 years extensively to develop various parts of this technology. Shell Oil and Gas is the investor in Manastu Space. IIT Bombay and DRDO are technology. IIT Bombay, DRDO, and ISRO have been technology partners where they have guided us at various instances to develop this technology. National Peroxide Limited provides us with a lot of raw materials, and we got our first seed grant from Lockheed Martin. In this journey, we have got various recognitions. As I told, we got our first seed grant from Lockheed Martin and DST. We have got various awards and grants from Japanese government, from JAXA, from DRDO. We have also represented India at various international forums like IAC, Top 10 Startups, Hello Tomorrow. In this process, we have also fought hard. We have worked hard to get 2 customers on board who wants their system on their satellites. We got our first development order from DRDO who wants this system to put on Indian defense satellites. We are currently in final stages of contract negotiation with a French launch vehicle company who wants this system on the final stages of their rocket for orbit corrections and orbit maneuvers of their final stage. So talking about the whole roadmap, we started R&D in 2016 with IIT Bombay, and from that time till now, we have crossed various technological reviews. We got supported hugely from ISRO, who did multiple technology reviews at VSSC and LPSC, which has really helped us expedite this technology development. Last year, we completed technology readiness level 6, where we proved the performance of the system on ground. And the immediate aim is this year we want to finish TRL 7, where we will be testing this system in simulated space environment in thermo-vacuum chambers. And going ahead, our goal is to test this technology in space by March 23 and start commercialization. So to sum it up, last 5 years with the general supports of organizations like ISRO, DRDO, IIT Bombay, we have been able to reach so far, so close to technology development. And in next 5 years, our major goal is we want to flight test this system, work on many use cases with our different satellite manufacturers and start commercializing this system. In this journey, we are currently looking for support. We are currently raising our pre-series round so that we can expedite this development process and start commercialization. We are also looking for support from ISRO so that we can expedite our flight testing and vacuum testing. And needless to say, we are always looking for passionate and uh, ambitious people, who can join us and run with us in this journey. So with this, I will conclude the whole journey of Manastu Space, and I will hand over this back to Isha. Thank you very much.
Thank you, Astesh. Now, so to proceed, I would like to invite Mr. Anil Prakash, DG, SATCOM Industry Association, to say a few words.
Namaskar, thank you very much. I think today is a Easter Sunday and it is a very auspicious day. So on this occasion, Manastu is completing 5 years, and I think is getting a blessing from the God and blessing for all Almighty and well-wisher friends. It was very heartening to see the growth of Manastu in last 5 years. How brick by brick they have built up that green propulsion system, which is unique in its kind. And I think this is India gift to the world. And as it is, uh, we see how our startups, deep tech startups are working in India. It is amazing. And we are at this moment, we are comparable to the, all the developing countries or developed world. So our startups are keeping us very high street. So my best wishes are with you, and we have a support from SATCOM Industry. We always will be with you. We will be working with the government to bring forth some policies and some development. Of course, we will looking guidance of Somnath sir for guiding the startup. He's always very keen and or evangelizing all the startups community. But we have to go a little more further, because I think you are the showing the path for the hundreds of thousands who's going to follow you. And your success is a success to all the people who are watching you. I think your number of startups which we have, I think they have the unique in their, they are bringing a unique solution, product, services in the satellite or space sector. I think it's very heartening to see them, and we see that the policies and the investment community and the government supports should remain, especially with the deep tech startups, so they should not find any problem in the day-to-day journey. And we have noticed that there are some teething problem which you are facing day to day. This is where the procurement of raw material, procurement of or testing of the product. Of course, ISRO is lending a great hand supporting you. But I think this overall we have to have a ecosystem developed where the industry, where the government and the investor community should work with the startup. So my all best wishes are with you, and that's all. Thank you.
Thank you so much, sir. To proceed further, Somnath sir, with your blessings and permission, we would like to unveil our new logo and website. Kindly allow us to do it.
Yeah, please go ahead. Yeah.
Thank you, sir. Thank you. This is our older logo and now the new one. So it represents harmony and sustainability in the long term. Space is not different from the Earth. It is already a part of Earth, and we can reap its benefits for the betterment of life on Earth. It represents space for all mankind. Like electrons going around the atom, it represents the fundamental building blocks of the universe. It represents wholeness, completeness. Like a vision of making Earth and space one, it is a symbol of oneness. Thank you. And now our website. Thank you. Thank you, Astesh.
Yes, so this is the latest version of the website where we have included our recent product portfolios, details about the technology, our team. You can, all of you can check out the products. There are three major products. One is iBooster, which is a propulsion system which we are specifically developing for use case of DRDO for larger satellites for greater than 100 kg satellite class. And then there are smaller propulsion systems which we are developing for smaller satellites, 5U to 24U class satellites. Please check out the details and we will be happy to connect more. And then we have also included the details of our in-space services, like what is the plan in future and how do we want to execute it. Okay. Isha, you can take over.
Can you run through
Thank
team
you.
after? Yeah, team.
Yes. Yes.
The link for that website is also shared in the chat box, so you can check it out.
Yes. So, so this is our team which is currently helping us to reach our goals. Mr. Venkat Raju, scientist CS Prasad, Amol Gokhale sir, Bellare sir, Bhargav sir, these are the advisors who are helping us. And this is our team who is currently working day and night to develop this propulsion system and put it out in space. And they include people from metallurgy background, people from nanotechnology, people from chemical, chemistry side. Yes.
Thank you, Astesh. I would now like to invite our chief guest, Dr. Somnath, to share his views on our topic for the day, sustainable future of space and the role of government, startups, and corporates. And I would also like to invite Tushar Jadhav, CEO, Manastu Space, to join the discussion.
Good morning, all of you. I hope I am audible, right?
Yes, sir, you're
Yes.
audible. Loud and clear.
Okay. Thank you so much for this opportunity to be part of your celebration of the 5th year of Manastu Space. And also very happy that you are unveiling the new logo and your website and also your product portfolio. From the presentation of Astesh, it's very clear what exactly is your goals and where the niche domain that you have selected for your work to continue. I think there is nothing to add saying that this is the best way for sustainability of space. One aspect is that it is green. You are talking about green propulsion. You are also looking at how the crowded space can be made better. And also how to show that the investment that we make for building a satellite can be stretched and prolonged, so you reap the best stuff out of it, what you have done. So in all your tasks and that your specific goals, the sustainability is always very clearly visible. So that's one good part I would like to address. Second is about my acquaintance with Manastu has been very long. Ever since that you came up with the satellite for launch in PSLV. That time we had opportunity to meet you people. Also came to know about your work in IIT Mumbai on the green propulsion, especially when you have been very successful in accomplishing some of those challenging early development tasks. And I want to tell you, all those who are listening to this, developing a propulsion system, an engine, though small for a satellite, is not an easy task at all. Those who are in this business, you do recognize that the challenges are many, many. Starting from a chemical composition of a propellant, though it's hydrogen peroxide with a proper catalyst, to get it appropriately, which synthesized to ensure a very stable combustion without any oscillatory behavior, instability, etc., is one of the important technical challenge I think they have overcome. Second, of course, is designing a chamber to fire it in and then have a sustained combustion with its own thermal, vibrational, acoustic modes and not getting excited. Produce required ISP, that is a specific impulse. That is the best out of the energetics of the propellant, chemical propulsion into thrust conversion. This process also is very critical, and this also goes through a lot of knowledge in the system that they have acquired through working with the people who guided them, and also the technical knowledge the team has acquired. It's not a small task. I want to appreciate them for their work in this domain. And it's not only the thruster. Now you come up with the entire feed system. The propellant is to be stored. You need to supply it to them. You need to operate it with the valves and controls. So the entire system becomes a very, very complex engineering by itself. And the choices of the material, the way in which it's integrated, the connections, the reliability of the joints, that it will survive the vibration environment, thermal environment, etc., etc. So all this adds complexity to the whole process. That's why the development process is a very painstakingly slow and steady, and reaching up to some success level. See, this I want to tell you that we all went through similar journey when we developed propulsion systems for launch vehicles and satellites. Never it looks so easy as it looks so easy to us today. It was so tough because we faced with failures after failures after failures in almost every propulsion system we developed. Starting from the solid, I know the stories of explosions after explosions. The next motor they make, it will explode. So every day there were explosions of various kinds. And the people who actually exploded quite a bit of motors and engines, they were the one who succeeded finally in building a very reliable liquid engines and solid motors in ISRO. I believe that you didn't went through that much of struggle in terms of explosions and damaging hardwares and facilities. So it's very nice because there were people to help you to come out with some good designs in the early part. So that is really wonderful to see. And also very interesting to see that you made a very compact version of the green propulsion system that can be connected to an existing or an already engineered spacecraft, where it will be useful for either deorbiting or for keeping its life longer in case it is needed. Also very interesting to note that you have an idea to refuel satellite with appropriate interfaces. So I am sure this will involve much more than what you have done today in terms of engineering of the system, which includes rendezvous, close proximity rendezvous, docking, connecting the fuel lines, connecting the gaseous lines, and transferring liquids from one unit to another, and also sealing the interface after the whole process. So this also is a very critical engineering work, which I am sure you will succeed someday, and you should be able to realize such a satellite refueling system. In fact, in ISRO, we have never even engineered such a thing. So I want to see that you people succeed before we actually build something. So the whole journey now, we are looking to enterprising youngsters, startups, industries to come out with engineering solutions for various space activities, much better than that what ISRO can do. See, I want to tell you, we have been in ISRO as an organization, we have worked in a very niche area. In India, especially to work in technology domains like space was never easy. Especially the challenges in space technology, many of you may be realizing. It starts from the fundamentals of science and technology, starting from material science, manufacturing challenges, which includes solid mechanical materials, metallic materials, non-metallic materials, energetic materials, the process engineering of many of them. Then comes the understanding of aerodynamics, control, interactions with structures and control. Then comes the electronics, the avionics, sensors, many number of sensors, its connection to the electronics, the whole data acquisition and processing on board. Then designing a huge number of facilities for engineering, manufacturing, testing, developing. Last 50 years, wonderful work has been done by the government-funded organization like ISRO. And achieving something of this nature is in a public sector undertaking in a government. It's not an easy thing at all. It is possible only by keeping a very large number of people very highly inspired. It doesn't work like a bureaucratic system. We work like a very inspired set of people. They come out every day with something new or the other to achieve something. So that inspiration that went into the veins of the organization, that kept many things happen. But now with 50 years of travel, we are looking at various different ways now. We would like to take many more industries, many more startups in this sector to come forward and take this mantle of developing very innovative solutions in India. The space activity in this cannot be confined to this public sector undertaking structure of governmental structure. It has to become much more oriented to solve the problems of various kinds. The mandate to Indian Space Research Organization was to solve the problems of our people serving in various sectors, and for that we developed technology. It was not for technology development we did, and it was not meant for the global community. It was not meant for building businesses. It was not meant for making money. No, the priorities were entirely different. Now the change has now happened. The priorities have to be looked at in a very different manner. The space sector is becoming much more different than which was earlier times. We just mentioned about the geopolitical changes that are happening. Ability to handle commercial space activities, ability to look at markets which are much beyond the Indian boundaries, solving issues which are more of global in nature than what is very local in nature, while continuing to work on solutions which are needed for the country in terms of various sectors like agriculture, weather forecast, disaster warning, education. All these sectors we should continue, but we also have to create bases in exploiting space sector for commercial purposes. As an economic driver, which will create more jobs and opportunities, will create a very vibrant space ecosystem whereby our cost effectiveness can be improved. We'll also find out markets outside the country where you can, we should be able to provide solutions for the global community. Various things are happening, and also it should continue to remain an inspiring and organization, inspiring activity for all of you people to come in and to create more startups of various types. So I want to thank Manastu Space as a very early part of the journey of startup culture in space sector. You came in, and I'm very happy to note that you have become successful in developing certain critical technology needed for space sector, and this is being offered to all of you, all of the community, all the space sector totally. Now, to take you further, you need to look at much more vigorously. So I know that you have been supported, very efficiently by many people who have already shown here. You need financial support, you need technology support, and I believe that you need much more funding and support from various people. I must take this as an opportunity, as an opening to tell you that it will be very nice for many of you, those who are listening to this, to come and then start investing in space. See, unless these young people are supported, very wholeheartedly to take this to the next level, building much more demanding system for the world. They need to spend very painstaking years in developing system inch by inch and then take it to this complex level. So they need continuous support, and in both financially, technologically. What ISRO can do today is to provide whatever facilities that we have in ISRO at the disposal of all of you. Whatever the least cost way that we can provide, the least troublesome way we can provide, we will try to do that. But then, of course, you need to be supported otherwise from various people, the funding and other support which is needed for you. I am sure it will come, provided you are able to show some successful result and a lot of business acumen in your presentations and in your portfolio. I think it is already there. I'm really impressed by the 3 green initiatives that are already there in this. So with this, let me thank you, Manastu Space, for all the very best for your further journey, and do not keep your enthusiasm limited to only this domain. You need to expand, because any startup in this, it has to have a strong domain, at least one area, but you should not limit yourself to one domain alone. It needs to be spread out, because you do not know where opportunities will come, how technologies will evolve. So you need to look further. So maybe initiating 1 or 2 more of related area of like the green propulsion may really be beneficial to you. And with that type of knowledge and skill, what you have already made, probably some more inroads can be made. And I want to tell you that we are ready to support in whatever manner we can. And there is a good system that we are now creating in Department of Space, both through ISRO as well as through InSpace. And you should definitely come through InSpace to make harness whatever power is there within ISRO. We are also looking at how better policies can be made in the space sector, which is going to be announced very soon. It's already in the industry consultation over, and we are going to government for clearance. And once the space policy comes in, the whole of the domain will really get revolutionized. I am very sure about it. I would like to see that happen in India in another 1 or 2 years. Large number of companies coming up, trying to offer solutions in complex technology itself, so that we will become one day the world leader in space technology, and we should be able to provide solutions for the entire globe from India, where there is a huge amount of technology talent available. So all the best to Manastu and all your team members, Tushar and this team, and really impressed by your presence, and thank you for being me here today in this program.
Thank you, sir. Thank you. Very interesting. It's always very interesting, enthusiastic to talk to you and listen to your view. So it's very interesting actually. Whole journey about how the ISRO has changed, because a lot of time people compare India with other foreign countries, but our mandates was very different and our requirements are very different, and our what we need to do for our people was very different. So I'll just we'll have next 15, 12, 20 minutes or so. We'll just go into some of the questions that we got through the people. And if anyone has any question, they can please post it into the box. So to start with, let me go top-down approach. So, sir, if you, as a pioneer in India doing space technology, and if you close eyes, how do you see the space in the world doing in 30, 50 years or so? What do you imagine we doing in that area?
No, your question is specifically to Indian
overall space, and then overall space. Then I'll come to India part and then startup part after that. So step by step. So overall.
Okay. No, see, first and foremost, let me go to the technology side.
Mm-hmm.
See, one of the core technology what we have is called the rocket propulsion. The space technology exists only because there is a chemical rocket propulsion which enables us to gain velocity from surface of Earth and then move to space. And even after the 70, 80 years of this birth, chemical propulsion, no single alternates to this technology has come to light even today. Various forms of technology people have been talking, tether, elevator and magnetic levitation, and so many things are there still in the talking domain. But in implementing a large scale propulsion technology, nothing has come really that can transform the whole process of rocket science. I look forward for something that will really revolutionize. Otherwise, chemical rocket propulsion is a limiting system, because the energy of the whole propulsion is contained within the molecules of the chemical propellant that you are carrying in some whichever way. Even if it is electrical, it has some fuel which is part of the whole system. So this is one thing which limits us from traveling beyond faraway places, possibly to exosolar planets, etc. So this is one domain which I would like to see a large amount of research taking place, and then significantly increasing in funding, etc., so that some real breakthrough happens here. There are many areas which I don't want to dwell on each of them. Second, of course, in the space sector is bringing down the cost of access to space substantially, which is already showing up due to various courageous interventions of private space entrepreneurs, that recovery and reuse of expendable rockets has really happened. They don't have to be called reusable rockets. They are expendable rockets very first, but they are also becoming reusable. So this drastic change in concept enabled the booster stages to be reused. But even today, reusing an upper stage is still a distant dream. The upper stage to come back and reuse, it is still very costly. because the velocities of the upper stages are very, very high. And to bring it back, you need to have a re-entry type of systems, and then wing the craft, etc. And there are work going on in this direction in the world, where I believe once you are able to bring back upper stage also, the cost of the rocket will come down still much cheaper. So this is the next revolution that has to take place. The third revolution, I believe, is in terms of electronics technology and intelligence into the spacecrafts and the overall electrical system. Even today, the electronics is bulky. Whatever you say, there are systems after systems which are to be integrated into a spacecraft. If you think about a 1,000-kilogram spacecraft, we have almost 400, 300 kilogram of electronics. It's mountings and things like that, which is making the whole spacecraft very heavy and costly. So this is where the real, the ingenious way of bringing our commercial electronics into space sector. Still, it has not happened. The space electronics is at least one generation behind the commercial electronics. Every day it is like that only. Primarily because of the reliability requirement of electronics demands that you need to create very large amount of heritage before we integrate into space. Whereas in mobiles and commercial electronics, the latest chips immediately enter and they go to the business. Whereas space, it is not so. So we lack in terms of the capability of a mobile even in a spacecraft, really. So this is the next step that we need to have. We find solutions by which the space electronics and the commercial electronics will be on par. Sometimes the space electronics must be next generation, actually much higher. How it can happen? It can happen only when the electronics become intelligent. Because in space, there are harsh environments like single event upsets and various other damages that are potential damages. If electronics is intelligent enough to handle those damages, repair itself and reboot itself and handle such criticalities in terms of memory loss or anything, then more commercial devices can go than the hard devices, so that the cost of electronics will come down drastically. The ability of intelligence in the spacecraft will improve, more autonomy will happen, and much lightweight, compact spacecrafts will become a reality. Then the next evolution is in terms of material science. So, materials are also very costly material for space, and varieties of materials gets in. The various approaches like additive manufacturing, functionally graded materials are revolutionizing the way in which propulsion systems and various other elements in space are being utilized. So here there are a lot of things, the composites, the ceramics, the metallic ceramics, additive manufactured products in every aspect of them. I think the way in which we treat materials will drastically change. Then homogeneous materials will vanish and will be really heterogeneous material concepts will come into space sector. And this is another revolution which is going to happen. Now, look at in India. In India, we are no way behind anybody. I think this is something which you have to understand. In terms of technology, what we lack today is in terms of our investment in space to create the scaled up products. So what we need today in India is to have sufficient confidence in building huge systems. We should also create some opportunity for the companies in India to have a global market access. Even if you build a complex system, if there are nobody to use, it will not really serve the purpose. So we should create that. These are very complex issues like geopolitical systems. The market access for space is not easy. So if you really make a very innovative product that the world cannot resist, then only we will have a possibility. Otherwise, it is not easy. So this is what we need to invest in terms of solutions to the global community. I want to tell you, Manastu, your idea of deorbiting is really wonderful. I know there are at least 10, 20 companies in the world working on deorbiting solutions today of various nature. So I would like you to come into the market and then show that yours is one of the low-cost method that nobody can actually resist from having it on your satellite. And there are international laws and regulations will come by which this becomes mandatory for somebody to put it. Your refueling kit will be, I must say, it is off the shelf and can be purchased and fitted and launched such a manner that every satellite service provider will definitely look for it. Only when such solutions come only that we will have a real market outside. So this is very, very important in India to gain. Otherwise, we will continue to develop systems which are similar elsewhere. Then there will not be any market other than what is the market within India. And within India also, we have a huge market. Let us not forget that part, that within India also, the services that we can provide to space sector is really huge. And I believe in the coming 5-10 years, the market of space activities and business in India will substantially increase, which is definitely going to be one of the important point that we need to consider.
So very interesting, sir. You mentioned about a very interesting touch point, the market access to Indian startups going internationally and the investment. So maybe if you can, any plans from, because in Europe and US we have seen, and there is a question in the chat box that they get a grants and they get a incubation support from the day one. So is there any plan, something that we can start, we as the startups who have gone through the journey, they can help, and also ISRO can be like a parent who can help the new kids. So any plans on that side, give some initial grant project?
Definitely, I think this is currently in the governmental sector, there are no plans for grants from as a department. We are already a grant receiving organization from Government of India. So we work on grants only from Government of India. So we cannot give grants as such, but the ability of InSpace, the newly created instrument called InSpace, they are looking into the whole policy of how to provide grants and incentives to startups in space sector. This is already an agenda in front of me, and we are going to discuss on how to enable such grants to come to you. Now, there are many ways of getting grants, either by creating a fund which can be created with government support, or through the large companies who are already interested in supporting various startups. They can be a partner and then support through the grants. So we will work out a plan next few months. We are trying to create an idea and then find out a means to solve this issue. It is definitely a top point in our agenda.
Interesting. And taking Indian startup, giving an access to foreign market, because ISRO has offices in almost all the major countries. So can we push, or say, through Indian embassies, as well as like the defense companies India is doing now, pushing it to the especially eastern countries. So something can be done for the space also. And there is an offset clause that is there in the defense contract that we buy. Can that be added to the space also in going forward? Future, is it possible? Because aerospace defense together?
Yeah, it is possible. It is again another topic of very serious consideration. The offset clauses, first about the offsets are not, though they are there, it's not happening in a way very satisfactory. I think this area we need to strengthen and create some activities in space sector, because such possibilities don't exist today. For example, companies to do some work for space sector in India is very limited today. So unless there is a sufficient ecosystem created, this offset work cannot happen.
Yes.
Of course, it is happening for various aircrafts and other businesses. Little bit are happening. But then into space sector, for example, building spacecrafts, building some launch vehicle parts, or building some engines here, and then using it for launch vehicles outside the country, or manufacturing launch vehicle electronics. So these type of things can be definitely handled here in India as an offset clause. So we have to first create industries who have world-class production lines in India. So this is the very, very important part. I am sure it will happen with the opening of the space sector. All this licensed production of systems in India will definitely happen, and people are waiting for announcement of opportunities, etc. Then coming to market access, I would like to tell you, through the embassies and things like that, the scope is very limited. Of course, we can market those things through international fora or international conferences, and such opportunities. For example, International Astronautical Congress, when you go next time when you are going to Paris, we would like to make sure that we are not going as an ISRO pavilion. We want to go as an Indian pavilion, so that ISRO and all ecosystems of space here in India, including private space enterprises, are represented in that pavilion. So this is how we want to look at it, so that we become rather the carriers of the entire space ecosystem of the country, not simply ISRO alone. So we can definitely do many things. But then I want to once again stress the point that the market access is purely on account of the merit of the case.
Yes.
So it doesn't come through anything else. The superior quality of the technical innovation, that will only drive the market access and cannot be coming from ordinary products.
Yes, so that is absolutely right. I mean, we can use all the force in the world, but if the product doesn't or services is not up to the standard, no one can help the company. That's for sure. So that is taken. So can you just shed some more light on the in-space and getting access of the facilities? What are the plans? We know the KC1 sir, he was involved some of the websites, and then what are the plans going forward? And how we can have a more clarity on the where the application is, what are the facilities. Can you shed some more light on it?
Yeah, yes. See, InSpace is constituted with an objective of one, to authorize. That is, those who are trying to get into the space sector, they requires a lot of support in terms of authorization. For example, those who want to build a launch vehicle need to go through the safety clearances, the launch clearances, things like that. And if you are building a satellite in India, then it needs to have as a repository of Indian origin satellite. You need to get the frequency allocation, the orbital slot allocation. There are a lot of such authorization requirements. If my video is clear?
Video has stopped, but I think you can continue. Yeah, now it is back.
Okay. I'm continuing.
Yes, sir.
Now, coming to the InSpace, the last 2 months or so, the Space Board has come into effect. Then all the directors have taken charge. Then new directors for promotion and the coordination, they have also taken their headquartered at Ahmedabad, and they will have a branch office at Bangalore also. Now the InSpace full function has really started. Earlier they were working in some temporary arrangement through the ISRO support. Now they are totally an autonomous institution. Then to support InSpace to function, sometimes I feel that my audio is not good. Can I confirm?
Yes, sir.
Can you hear me? It's okay.
Yes, sir. Yes, sir. We can. Yes, sir. Yes, sir. We can hear.
Okay, now you can ask your next question. Otherwise, now we lost the continuity. Yeah.
Yeah, yeah. No issues, sir. No issues. So, so I'll just dive down to a little more about understanding how the ISRO makes about the technology and the developing a complex project. So how does it, what is the secret, if you ask me to, deep look inside and just find out what is the core beliefs, the values, or the things that ISRO does so that it can create such a reliable, consistent product over the success, and how the ISRO keeps the team motivated, inspired for such a long time. So product as well as the team, if we can share some more light so we can learn as a startup.
So you asked about the culture and the inspiration of Indian Space as an organization, how they are able to do wonderful work. So it will not be easy to understand unless you are an insider. See, for example, if I talk about my own story, then you will probably understand. See, I joined a PSLV project team. At that time, the team leaders were all the people from SLV3 era. See, after Kalam, his associate of Abdul Kalam was the project director of PSLV, Dr. Srinivasan. Probably you may not know him because all of you know about only Kalam. You don't know about who were the other people. So Dr. Srinivasan was the architect of SLV3 in terms of engineering work. So he was there as our project director, and the entire team with him was the SLV3 team that actually went into developing PSLV. So when I joined as a young engineer, I will tell you, when I came there, I was given the very first day, I was given 5 tasks. I did not know ABCD of that 5 tasks, what to do. I was wondering what to do. Then there was no class, no training, nothing to you. You just fresh from engineering college and you are trying to do some complex work. Then what you do is you simply go around and meet people. So we went around the institution at various people who will likely to know this subject. We go there, we discuss with them. We went around and learned from people and then try to do something. And we were allowed to fail. I want to tell you that I, as a young engineer, how many times I failed, I do not know. Every time I do something, there is always a failure. And we were encouraged to make failures. And we were encouraged to take decisions. In younger age itself, we were given authority to take decisions. And we will manufacture, fabricate whatever we like to do, and we test it, and then come and tell our boss, yes, it worked. Okay, it didn't work, fine, it doesn't work. So in fact, many of my effort in PSLV time, I met with many problems and failures. You mentioned today before the meeting, you saw some bolts being carried in very fine cover and torqued, and see, all this learning came to us not by accident. It came through many failures. At least I have seen in my life at least 10 times fasteners failing and causing real havoc in joints. See, after you understand that it is so critical to the building a system, you need to understand it much more detail. Today, I know our engineers in this area understand a nut and bolt in such greater detail than you will ever study in engineering college. See, there are so many aspects related to a simple nut and bolt with regard to its threads, its lubrication, its tolerances, its characteristics of the washer and the head and the surface finishes, the material combinations, the reuse of a fastener, how it alters the behavior of a fastener. Talking of versus talking of a head, how it will changes the characteristic. No, there are hundreds of parameters that govern a fastener usage in nut and bolt or a tab to hole or a machine hole, or what process you made to use, whether it is a turning process you realize the nut or the bolt, or through a thread rolling process you realized, and whereas a hardening done post of that. So parameters after parameters you need to characterize and understand. Even today we are studying and learning a nut and bolt. Even today, it is not ended. The understanding of a nut and bolt has not ended even today. So this is never taught in a college, I want to tell you. And similarly, there are so many aspects when you design a rocket structure. I have been an engineer who designed so many structures of a rocket, and every fastener we say, a typical structure of a rocket is made out of something like 3,000 rivets, or sometimes that many number of fasteners. And my boss used to be the former director of LPSC, Dr. Sri Perumal. You may know him. He is one of the finest engineer I have ever seen. He will tell you every rivet is critical. If one rivet fail, the entire structure will collapse. Oh, then we look at it and look at with such a scary eye. Oh, that simple looking rivet, if it fails, the whole rocket will fall down. The truth is that it is true, because the rivets are placed in such a manner that between rivets, the spacing is such that it will buckle only within 10% of confidence if the rivet is there. If the rivet is not there, it is guaranteed to buckle there under the expected load. So it is true in electronics. If a single connection out of lakhs of connections, if it disconnect or have a chatter, then the mission is likely to fail. So you are told this every day and out. So you pay attention to details, to a level that you can never imagine. And these questions are asked on by different types of people. Have you gone to this? Have you studied this? No. And then you'll criticize alternate solutions. Then by this process, you become such a cynical person that all of us are very, very cynical. No, we tell that it will fail first. Whatever you make, that it has a potential to failure. This is what we understand. And once with that eye, you look at everything. Then you will understand the knowledge you need about the material, the welding, the processes, the manufacturing processes, the testing, level of testing, the test data when it comes out, how do you analyze the data? The rigor and the questioning, asking mindset is very, very, very complex, and nothing is given to chance. And whenever we have given anything to chance due to whatever unforeseen things, we had failures. Okay, I can guarantee that you leave anything to chance, anything to some big man told it will work. If you say a big man looked at it and said it will work, then no guarantee that it will work. So we have to be proven on paper by calculation, by analytics, by theoretical foundations that it will work. This proof is required every time. And even in softwares, we had failures. The first PSLE failed because of a software failure. And it is precisely because we did not establish a very rigorous way of understanding softwares and the ability to test them. So I want to tell you the simple quality is to have a very critical mindset and also very cynical approach. Every successful space system is because of a set of people's mindset. They have to be trained to create a mindset which is always very, very questioning nature. And if you have developed such a nature of that tomorrow it is likely to fail, that nature is there inside your designers, you will make a wonderful system.
Interesting. I can relate to that of the O-ring that failed in one of this space shuttle, and I can imagine a world can actually do that same damage. And yes, sir, absolutely. So so thank you for the very interesting. So before we close it out, it's already on the time. We just have one, maybe a second last question, maybe. We have a lot of students here, so and the people who wants to enter into the space. So any message, any skill that they should incorporate that will be needed for tomorrow.
See, the space technology is nothing special, really. It is normal engineering sciences only. The electronics, the mechanical, the chemical sciences that makes everyday products possible. It is the same technology, but the way in which we do is slightly different. No, the ability to build a bridge versus building a structure of a rocket, they are entirely different processes. Even if you don't have full idea of some of the elements of the bridge, it still work because the margins there are 5 and 6. So even if something you didn't put right type of reinforcement there, it is likely to work. But in a rocket system, there is no chance. So the first and foremost ability of anybody who would like to get into space is to have at least one domain having such a deeper understanding, so that you can actually contribute substantially to that domain. So it will not come from textbook knowledge at all. That I can guarantee you. Even in a university of the best of the university, if you teach them, still you will not get it. You will get it only working with people who have already burned their fingers. That knowledge you cannot get from anywhere. This we have learned very, very clearly, because many experts who have burned their fingers, they know that this approach can lead to failure. But also this has a danger also. It also prevents innovation. See, if you take too much of advice from very seniors who have done great works, it will prevent you from innovating. So you need to strike a balance, So I always do this in an organization where there are very young people who have a lot of good ideas and very old people who are very cynical. It is very difficult to push new ideas. But then, as a director, I have always done this. I always listen to youngsters who wanted to do something very differently, but then seniors, they will tell you never do this. For example, one example is this use of quartz electronics in space. Quartz means commercial off-the-shelf electronics devices in space electronics. But we know it has to be done. If you don't do it, then we are never going to make electronics cheaper. But if I go to an expert who has spent 30 years in electronics and building space electronics, he will never allow you to do that. He will tell you that you need to get a space grade milk component, and it has to have a derated to such and such levels and things like that, which is quite a violation. So there are manufacturing processes which will conventional very safe approach people will not allow you. So I want to tell you, those who want to get into space must keep a mindset of these two conflicting mindsets. If you want to innovate, you need sometimes break the jargon, break the way regular people do approach it, which is very, very difficult. And also you should have a safe approach mindset. Otherwise you will face failures where you can never recover easily, because the money that is pumped into the system is too much that you cannot recover easily. So it is a balancing act. Then second is you need to have, as I told earlier, you need to have a deeper understanding of at least one domain that you have selected. And in that you need to be the world expert, not simply more average fellow. An average fellow will only do an average job, and an expert only can do the best job. So develop an expertise, and all of us have an ability to develop expertise at least in one subject. I am very sure about it. In one domain, at least we have. I am very sure about it. And once you have that expertise, I think you will be able to appreciate the expertise of others. And once you are able to appreciate the expertise of others, you know how to work in a team. So once you know how to appreciate others, you will definitely develop an ability to work as a team, and then you can do great things. Being an expert in one domain, you will never be able to do anything. And be an expert in one domain, but catch hold of some more people who are experts in their own domain and work as a team. Then you will definitely build great systems and great contributions you can do to the space. So just ordinary people with expertise coming together will make space system possible in India. I am very sure Manastu is an example of that. All the very best to you, youngsters.
Thank you, sir. Thank you. Very interesting. So one last question. Any advice for a startup in very short, things that they can do better or they need to focus on something on that to startups?
No, startups, see, I am not a right person to advise startups. See, please understand, I am an old generation man, no? See, I belong to the 80s time frame. If I start advising youngsters, it will be a wrong thing to do. And I always realize it. Because, see, I can only advise from what I have learned and experienced. But your generation has a different mindset and the ability to think, which is much beyond. But I can understand your thinking, and sometimes I will be able to moderate, because this moderation is also important. So it is through the they are clueless. Now those type of times, definitely I look forward where I can help you and then take you along. So that's what I am equipped to do because of my experience and working in this domain. So otherwise, youngsters, I should not advise. I have realized it long back. Thank you.
Thank you, sir. Thank you. Very interesting. So we are looking forward to working with you and ISRO, sir. I mean, our journey of space started with ISRO, and probably it will go a long way. And we'll, looking forward to do a lot of things and supporting in a very small way ISRO, and then ISRO also supporting in us so that we can grow together. We are looking for that, and we'll have a more and more face-to-face meeting discussions and get a feedback. We would like to present our technology in more detail, and what are we plans, how are we doing the testing results, and in a short, so that we can, if we can use it in any ISRO project going forward once we prove it, and help in flight testing as well as thermoactive testing. So we'll come to that, come to you through InSpace and proper channel, and we'll need your help for that. So I think I'll hand it over to Isha. It was thoroughly a interesting session. We love talking to you as usual, and getting your views, and very open-hearted and openly discussions. And I personally enjoyed a lot. So I'll hand it over to Isha. Okay.
Yeah. Thank you, sir. Thank you, Tushar. We're almost at the end of our session today. Before we end, Somnath sir, can we click a virtual picture with you?
Yeah, of course you can. You have been recording all the time. Anyway,
Anil sir also, if you can join.
all those who are only showing their names can switch on the video.
Team Manastu, if you can, some of the people, if you can switch on the video. I'm just putting them on a stage. Just a moment. Huh?
Well, sir, on a defense offset, we had interaction with defense, and we will happy to share with you a position paper which Satcom Industry Association has just finished, and it has touched upon how the private space should be included into defense offset obligation. So that we will share with you, sir.
Sure. Please do that.
Yeah, I think we can take it with the people available. Isha?
Yes. Thank you everyone. Now,
Thank
before
you.
ending, we have a short clip about Manastu Space. Can we have the video, please?
Yeah, you can play the video. I can share it on the screen.
Yeah, please let me know if you are able to hear the audio as well. Okay.
Yeah. The audio is not there. You can share the video, no problem, Astesh. Okay. Yeah, we can hear it. So this is our catalyst team where we synthesize our high temperature, ultra high temperature ceramic catalyst. We're doing some work related to propellant stability testing, storability, group discussions. On the thruster related work. This is before putting the thruster into testing the preconditioning, and this is some of the thruster firing that. So in this case, for this thruster we are targeting at least 260 Newton monopropellant based thrust, 260 second ISP for 1 Newton monopropellant based thruster. So that is a major work that has been going on, and major development is in the catalyst fuel and the engine design.
Thank you, Astesh. Thank you, Tushar. On behalf of the entire Manastu family, I would like to thank Dr. Somnath from the bottom of my heart for taking out time from his busy schedule to be here with us today and making our day even more special. Your words have enlightened us, and we hope we can keep learning from you in the future. I would also like to thank Mr. Anil Prakash for his kind words. Lastly, I would like to thank all of you from across the world for being a part of our celebration. Thank you all. You can also follow us on our social media handles. The links for our LinkedIn, Twitter, and Instagram are shared in the chat box. Thank you so much.
Thank you.
Thank you, sir.
Thank you, sir. Thank you so much. Thank you,
Bye
everyone.
bye.
Hello.
See you. Thank you, sir.
Bye.
See you. Bye, bye, bye. Thank you.
Bye.